All right, hey guys, this lesson is going to go through lesson 9.6, and we're going to be learning about recursive rules and sequences. So by the end of the lesson, you're going to be able to find the first few terms if I give you a recursive formula, and you're going to be able to write an explicit and a recursive rule specifically for geometric sequences. Okay, we already kind of did this with arithmetic sequences, but we're going to review it now with geometric. So first thing, a recursive formula allows you to find terms in a sequence by performing an operation such as adding, subtracting, or multiplying the previous term. Okay, so basically what that means is I'm going to try to find a rule, like if I give you like 5 and then 8 and then 11. Obviously, you know what the next three terms are because of the pattern. So a recursive rule is a rule that you can use to say like, hey, if you know the third term, you can find the fourth term just by adding 3 more to it. If you know the first term, you can find the second term by just adding 3 more to it. So that's what a recursive rule looks like. So that's what we're going to be going through today. Okay, so I'm going to show you what the rule for a recursive rule looks like for a sequence. So if you can go up to the gray box where you have a little room up by the learning intention, I want you to write this down. Okay, this is what a recursive rule looks like. So I'll give you a second to copy this. And then I'm going to talk about what each part means and try to talk you through it. Okay, first thing, if you see this little notation, A with the little 1 below it, that is the first term. Okay, so I already know right away, hey, the first term in my sequence is 10. So if I wanted to make a list of the terms in my sequence, I'm just going to come down here and I'm going to say, okay, I know the first term is 10. Okay, now I'll show you what each of the other parts means. If I'm given this, that A with the sub n there, that tells me I'm trying to find the next term or whatever term number I'm trying to find. Maybe I'm trying to find the second term or the third term, okay? It's telling me this A to the n minus 1, that actually stands for the previous term. So it says, hey, you're going to take whatever the term was before it and you're going to add 3 to it. Now here's kind of why that works. I'll try to show it to you in pink above it. So if I'm trying to find the second term, I'm going to say, okay, I'm trying to find the second term. Okay, I'm going to plug a 2 in where that n is. Now look what it says. If I work this out, 2 minus 1, that's really 1. So it says, hey, you're going to take whatever the first term is, add 3 to it. So if my first term was 10 and I add 3 to it, I'm going to get 13. Okay, now if I know the second term is 13, think about this. Now I want to find the third term. So I'm going to do the A with the 3 minus 1 here plus 3. Now if you work this out, 3 minus 1 is 2. So it says, hey, take whatever the second term equals, the value of the second term, which is 13. And add 3 to it, which gives me 16. Now if I wanted to find the fourth term, or the value of the fourth term, I'm going to do A and then 4 minus 1, which really equals 3. So I'm going to take whatever the third term was, which was 16, and then add 3 to it, which would give me 19. So that's kind of what the rule looks like for a recursive rule, and this was for an arithmetic sequence. So let's actually try example 1. So it says, hey, if I give you the recursive rule, can you actually find the first 5 terms? Okay, well, it's pretty easy if it gives you the first term. A to the first is 10, so I'm going to list that. And then all this rule says is you take whatever the previous term was, add 3. Well, that's what we just did, actually. So I get 10, 13, add another 3 to that, 16, 19, 22, and then it keeps going from there. Okay, so let's try the second one together, and then I'll have you try the third one. So again, it tells me, hey, my first term is 7. And again, this means take whatever the previous term was. So if I'm trying to find the second term, I need the first term, take away 9. Well, if I do 7, take away 9, I get to negative 2. Find the next term, I'm going to do whatever I had before, the second term, take away 9, which gives me negative 11. Again, take away 9, which is negative 20, take away 9, which is negative 29, and it keeps going. Okay, why don't you pause the video, you try the third one on your own. All right, first term is 5. Now this time it says do 2 times whatever your previous term was. So now instead of doing 5, like adding, this time I'm going to times it, which would give me 10. Then I'm going to double that, which is 20, 40, 80, and then keeps going from there. Okay, so now our next learning goal is, hey, could we actually write the recursive rule for the sequence? So if I give you a sequence, could you write the rule? So first thing you have to do is try to figure out, hey, is it geometric, arithmetic? What's happening here? So if I look at this first one, from 16 to 48, from 48 to 144, you need to figure out what's happening. Well, it's tripling, and you could use your calculator to figure that out. Okay, so my common ratio is 3. So if I want to write a recursive rule, you always start by putting this. I'm going to say, hey, here's my first term. You always need to tell me, what's the first term? Well, the first term's 16. Okay, then to find any term, we'll put a to the n. You're going to do, what are you doing to the term before, the term that you know? So if I know the first term, 16, well, I'm timesing it by 3. So I'm going to say whatever the term before was, a, and then the little n minus 1, I'm going to times that by 3. So I'll sneak a little 3 in there. Right in front of there. So I'll write that better. 3 times whatever the term before was. There is my recursive rule. Okay, let's try the second one. So first thing you need to figure out what's happening from here to here, from here to here, from here to here. Well, it's actually timesing by something. It looks like it's halving, so it's timesing by half. But now if you have to watch your symbols, to get from a positive to a negative, it's timesing by negative. Negative times a negative get me to a positive. So it's timesing by negative a half. So again, it's a geometric sequence. So first thing I'm going to do is say, hey, my first term is 224. Okay, to find my next term, I'm just timesing it by a half. So I'm going to say, okay, to find any term, or the next term, I'm going to take the previous term and then times it by a half, negative a half. So I'll put negative a half. There is my recursive rule. So just so you guys know, this whole thing here I'm highlighting, this is all the recursive rule. You have to have both parts because you need to know that first term for a recursive rule to work. Okay, and then why don't you pause the video and you try the third one. So if you look on the third one, you should have found the pattern was adding 8,900 each time. So this one's an arithmetic sequence. So if I'm going to write the rule, you start out the same way. I'm going to say, hey, the first term is 100. Okay, and then to find any other term or the next term, I'm going to take the term before, so I use that notation, and add 8,900 to it. So again, this whole thing here is your recursive formula. All right, so the next thing we're going to look at is recursive formulas and explicit formulas for both arithmetic and geometric. So you already know the recursive formula, so let's start with that for arithmetic because that's what we just have been doing. And that actually is a pretty easy one. So the recursive formula for this one right here, it looks like it's adding 3 each time, would be, I save my first term, a to the first equals 10, and then I say, okay, to find any term, I do the term before it, and remember this is how you write it, and then plus 3. That is the recursive formula. Now, remember, this is kind of from the past. An explicit formula looks a little bit different, and we learned 2 ways to write it. One way I kind of like a lot better. So the explicit formula would be like, hey, can you find any term in the sequence? Okay, and this is just as a quick refresher. So for an arithmetic sequence, here's what I kind of told you. So you find, like, what's the common difference? It's 3. That's kind of like the slope, what it's changing by each time. So I'm going to write 3n. And then plus, this relates to, I should have said this, it relates to a linear function. So it's like a line. So remember, this is kind of like the slope or the common difference, and then you need like the y-intercept or the 0 term. So if you went back 3, it'd be plus 7. That's really what the explicit formula looks like. Now the other way to write that is like this, and I don't really love this way, but I'm going to show it to you. Okay, what you can do is you can take the first term, which is 10, okay, plus the common difference goes right there, 3 times n minus 1, where n is the term number. That's the same case here. Now, you might be like, hey, those look way different. They actually, if you multiply this out, it would end up being the same, because if I do 10 plus, if I distribute 3n minus 3, I still end up with 3n plus 7. So that's the explicit formula for an arithmetic function. You can use either of these, but I just want you to be able to pick out how both of those work. Okay, so now with geometric sequences, I want you guys to think about what they kind of relate to when we've been working with geometric sequences. This whole chapter is on exponential functions, so those relate to exponential functions. So the formula should kind of look like that when you get to the explicit rule. The recursive one is pretty easy to do. So let's start with the recursive, or let's start with the pattern first. So clearly it's doubling, it's timesing by 2. Okay, so my recursive formula, again, you start out by saying, hey, my first term is 6, and then to find any term after that, I take the term before, remember you put that, and then I am going to double it, so I'm going to squeeze a little 2 in there. Usually I try to leave a little space, so 2 times that. There is my recursive formula. So now my explicit one, remember, it has to relate to an exponential function. So it's going to have an exponent in it. So here's how it looks. You say a to the n. We just did this, so this should be pretty clear. It's doubling, so I'm going to have 2 to the n. And then you need, basically, you kind of have to go back and get that first, or the 0 term again, like the starting amount, which would be 3. Now, if you're ever not sure if that rule is correct, again, I just went back and divided by 3 to get kind of like the 0 term. If you're ever not sure if it's right, plug it in. Let's try the third term should be 24. So if I do 2 to the third, that's 8 times 3 is 24. So I know my explicit rule is correct. And this should be really familiar because we just did this the other day. Now, I do want to show you the other explicit rule, like the correct one for geometric sequences, and we saw this the other day. It's you could take the first term, so 6 times the multiplier, which is 2, and then to the n minus 1. So that would be like whatever term you're trying to find, one less than that. So again, these will end up giving you the same thing. So let's just test it again. Let's try for the third term. If I was trying to find the third term, it should be 24. I do 6 times 2 to that's the third term. So I'll put 3 minus 1. Well, 3 minus 1 is 2. So if I do 2 squared times 6, well, that's 4 times 6 is 24. So when I tried to get the third term, it worked. And again, if I try to do this up here, 3 times 2 to the cubed, 8 times 3 also gives me 24. This is like the correct rule for a sequence, but this one I think is easier to remember and find. So I will take either of those when we're doing problems. Okay, let's go on to another example. Example 3. So I have a zombie movie has a virus causing the spread of zombie-like creatures. The table represents the data collected about the virus. So like on day 1, there's 3 infected people. On day 2, 12. Okay, so first thing you have to decide, is this arithmetic or geometric? Okay, so take a look at it. Well, you can probably quickly see a pattern. It's timesing by 4, so that means it's a geometric not series, sequence. I should say sequence. And how do you know? Because it's multiplying by 4 each time. All right, the recursive rule. Go ahead and try to write the recursive rule. All right, so I'm going to say, hey, my first term is 3. And then if I want to find any term after that, I write a with the sub n. And then I am multiplying the previous term by 4. So 4 times, and then here's the previous term. Okay, if we want to write the explicit formula, again, since this is geometric, it relates to an exponential function, so it's got to have an exponent in the rule. So I'm going to say, okay, a to the n to find any term. Okay, it looks like I am doing, it's quadrupling, so 4 to the n, and then I need to go back and get like on the 0 day. Think about if we had zombies, like what did it start with? So if I go back and divide by 4, well, 3 divided by 4 would give me 3/4, or you could write 0.75. Again, one last thing, you could check this out if you want to by plugging in like a 2, the second term. So I could say, okay, let's do 4 squared times 3/4. If I do 3/4 times 16, simplify that, I end up with 12, and that's what I should have. So I know I wrote that correctly. Now let's do the other rule, like the technically correct one. I'll do it in blue over here. So to find any term, again, you can start with the first term. So I can do 3 times, the multiplier is 4, and then to the n minus 1. Again, let's just test out 2 if I'm trying to find the second term. do 3 times 4 to the 2 minus 1. 2 minus 1 is 1. So 3 times 4 is 12. So again, both of these rules work. This one here and this one here. They're just written differently, and you can choose either one. All right, let's go ahead and try example 4. So Maya bought a new car with a loan from her dad, and she pays back the loan. So first thing, let's go ahead and see, is it geometric or arithmetic? What kind of pattern do you see? All right, and again, you can use your calculator on this. It looks like I'm subtracting 4,400 each time. So this definitely is an arithmetic sequence because it's subtracting 4,400 each time. There's a common difference. So recursive rule, this is the easier one, I think. So I'm going to say, hey, a to the first is 17,600. And then to get the next term, I'm going to say you take the previous term and you subtract 4,400. And that would give you your next term. The explicit rule, since it is arithmetic, you could write it 2 different ways. I like to do it like this. I'm going to say, okay, it's changing by 4,400 each time. So I'll put 4,400 n, and then I need to go back and get like kind of like the y-intercept because it's like a linear function. And I go back 4,400. Actually, if I add 4,400, right, do the opposite, I get 22,000. So I'm going to say plus 22,000. That would be my explicit formula. Now, if you wrote it the other way, I could say, okay, here's a to the n. I could say, hey, my first term is 17,600 plus the common difference is negative 4,400 times n minus 1. And again, if you work that out, these two things are going to equal the same thing. So I would take either of those answers. Okay, so now I'm going to have you try the March 4th class kick. So please try that out. If you have questions, you can ask Mr. Knight for the answer key, or you can go ask Mrs. Stefanik as well.